Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video describes how to calculate the minimum sample size needed to estimate a confidence interval for population means. Let's get started. So, we saw in an earlier mini lecture how to calculate the minimum sample size needed to estimate a population proportion. And the equation that we're going to use for getting the minimum sample size needed to estimate a population mean is going to look very similar. Here it is. So we've got our critical value z-score multiplied by our population standard deviation divided by our margin of error, and then the whole thing squared. So a little different, but in many respects, it's very much the same. So as we saw before with with proportion sample size, we're always going to round up to the next whole number because we want to make sure we capture that partial person or member included into our sample. Of course, in order to use this equation, we have to know what the population standard deviation is. So in those events where we don't know what the population standard deviation is, and that's true most of the time, there's one of three options that we have to pursue. First option is we can use the range rule of thumb to estimate the population standard deviation. Second option is we can collect some data values initially and then use the sample standard deviation as an estimate for the population standard deviation. As we collect more sample data, we can then make a new estimate of our sample standard deviation to estimate the population standard deviation. We can also use the results of an earlier study to estimate the population standard deviation. So three different options that we can use, and really it's just a matter of professional judgment to know which is the best one, and that comes with experience. So the more experience you get with working this sort of thing, then the more you're able to discern which of these three options is the best one for your particular case. Let's look at an example problem involving IQ scores. So let's assume we want to estimate the mean IQ score for the population of statistics students. How many statistics students must be randomly selected for IQ tests if we want 95% confidence the sample mean is within 3 IQ points of the population mean? So to proceed with this problem, we need to recognize first that a 95% confidence level means our significance level, alpha, is 5%. That means that Z alpha over 2 is going to be 1.96. We then plug in what we know into our sample size equation. And we're going to use a previous study that suggests that the population standard deviation is 15. So with those values plugged in, here's what we get. Notice the 3 for the value of the margin of error. It doesn't say 3 percentage points, it says 3 points. And so therefore we're going to put that whole number 3 in and not 3%. Punch this out on the calculator and we get 96.04. That's the minimum sample size that we need. Of course we're going to round up. That's going to give us 97. So our minimum sample size for us to construct our 95% confidence interval on the sample mean is going to be 97. However, with a simple random sample of only 97 statistics students, we're going to be 95% confident the sample mean is within 3 IQ points of the true population mean mu. 97 is not really all that much, but that's the way the numbers work out, so that's what it is. Let's look at another example involving time on Facebook. How many internet users must be surveyed to know with 95% confidence that the mean amount of time internet users spend on Facebook each month is within 15 minutes of the true value? A recent survey reports that the population standard deviation is 210 minutes. So go ahead, stop the video here, try to work this on your own, then come back and we'll see how well you did. All right, let's see how this works. First, we need to calculate critical value z-score for the 95% confidence level. Why is z-score? Because the key question is, do you know what the population standard deviation is? Here they're giving it to us in the problem, the 210 minutes. So therefore, we're going to use the standard normal distribution, calculate a z-score critical value. If we put those numbers in a stack crunch, out comes a 1.96. That's going to be the number we use for calculating our margin of error. So, or rather, we know what the margin of error needs to be. We're just going to have to now calculate the sample size. So here's our sample size equation. Okay, notice the values that we're putting in here. The 1.96 are critical value z-score. 210 is the population standard deviation from the problem statement, and the margin of error 15. That means what we're saying here is we want to be within 15 minutes of the true mean value. So this within 15 minutes, that's your margin of error, which is the 15. Punch that out in the calculator, and we get a 752.9536, which of course we're going to round up to 753. 753 is then the minimum sample size that we need in order to construct that 95% confidence. Now, what is the major obstacle to getting a good estimate of a population mean? What say you? What do you think would be a major obstacle? Well, certainly one major obstacle to get to this completing this type of project is getting good data. And that's typically an obstacle that you see with a lot of real-world applications. Facebook isn't likely to self-report trustworthy data. I can remember being in industry and, we all knew, okay, those of us that were in the industry, we knew that we were reporting numbers that were, slightly skewed to make us look better than what we really were, because we knew that our competitors were doing the same thing. They were reporting numbers that were also slightly skewed to make them look better. So the data that everyone's reporting out in the open for all the public to see is not exactly completely trustworthy. And Facebook's not going to be any different here. Okay? So how do you get accurate times unless you're like hacking into people's computers or stalking them? Okay? Which of course you don't want to be doing either one of those things. Both of them illegal, and there's some severe consequences to those. So yeah, you want to stay away from that. But it presents a problem, right? So it's like, if you can't get the data that way, how do you get the data? How do you get good data? This is a question that often plagues real-world analysis when you're dealing with statistics. Getting good data is often a major obstacle. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.